So what we've been asked to do here, so we've got this reaction. We've been told that perchloric acid, which we've got here, reacts with phosphorus pentoxide, and that produces phosphoric acid and dichlorine heptoxide, right? And we've been asked to balance it, and the question also specifically specifies that we should use only whole numbers when balancing the equation, right? And we've actually also got, in this case, we've got a bit of a representation of the structure. Not that we need that representation per se, but I've just added that in there, so to give a bit of a visual perspective on what the reaction, what some of the molecules roughly look like, right? Which are like the reactants and products. Okay, so how am I going to approach the actual balancing process for this? Well, the first thing I'm going to do is I'm going to work on figuring out where do things stand currently as far as the elements and the frequency of occurrence, both on the reactant side of the equation, so the left hand side, and on the products side of the equation, right? So on the right hand side, right? So effectively I'm looking at, okay, so for the left hand side and the right hand side, so we've got hydrogen, we've got chlorine, we've got oxygen, and we've got phosphorus, right? So HClO₄P, okay? And so what I'm simply going to do is just audit both sides and figure out, well, how frequently does each element occur on each side currently, right? So for hydrogen, you can see it occurs in this species, the perchloric acid, so it's going to be 1, right? Chlorine, you can see again it only occurs in the perchloric acid. We're going to put a 1, right? And for the oxygen, this occurs in both species, right? So it occurs in the perchloric acid, and it also occurs in the phosphorus pentoxide. So what we're going to do is just add that up. So this is going to be 4 plus 10. So that's, of course, that's going to be 14, right? And phosphorus occurs only in the in this species, right? So, and we've got a 4, so that's going to be 4. So if you bring our attention now to the product side of things, so for hydrogen, it occurs only in this species, right? The phosphoric acid, so we've got 3. Chlorine, it occurs here, and it occurs twice. Oxygen occurs in both species, so that's going to be 4 plus 7, so that's going to be 11, right? And as far as phosphorus, it occurs in the phosphoric acid once, so I'm going to put a 1 here for that. Okay, so what can we see here? Well, basically none of them are balanced, right? We've got different numbers on both sides for all of them, and so I have to devise, well, which one am I going to try and make some level of effort to balance initially, and then go from there. One of the things that I can see here is we could try to address the phosphorus, right? So if I do try and address the phosphorus, where we've got an occurrence of only 1 on the right hand side and 4 on the left hand side, so you've got 4 more on the left hand side. If I add a coefficient of 4 on the phosphoric acid, we would in effect get 4 phosphorus. So I'm going to try that and see where that gets me, right? So the new equation, I'm going to write that out. So HClO₄ plus P₄O₁ produces, and then we're going to have a 4 here, right? So 4 H₃PO₄ plus CO₂O₄, right? Okay, so we didn't actually change anything on the left hand side of the equation, so that more or less means it would be the same, right? So when we write out, so for the left hand side here, so on the left hand side it would be the same as what it was before, so 1 1 14 4. On the right hand side we did change something, so let's see how our modification affects things, because it doesn't just affect the number of phosphorus, which is what we were mainly focused on. It has also, you know, you could describe as collateral effects on the number of hydrogens and number of oxygens, right? So let's look at the number of hydrogens first. So we've got a 4 here, so we're going to have to do 4 times 3, right? So we would effectively have 12, right? So we'd have 12 hydrogens. And for chlorine, we didn't, it only occurs in this species, right? So the dichlorine heptoxide, we didn't change it, so that stays the same as what it was before. It remains 2. But for oxygen, remember we've got the 7, but then we also have 4 times 4, so 4 times PO4. So that would be, here we've got 16, right? And then to the 16 we need to add 7. So that's going to give us 23, right? So for oxygen it's going to be 23. And then of course our main aim, right, for this part was actually the phosphorus part. So for phosphorus we're going to get a 4, right? So as you can see, when we compare both sides now, you know, the phosphorus has changed. So we've got a bit more, you know, it's a bit more balanced in terms of the phosphorus, but the others are still not equal. Okay, so what could we try next to try and get closer towards our goal of having a balanced equation, right? Now, one of the areas which we can see is quite unequal would be the hydrogens, right? So we've got 12 on the right hand side and only 1 on the left hand side, and the only species in which hydrogen occurs is the HClO₄. So in this instance, what we can try and do is put a 12 effectively in front of the HClO₄, just to try and increase that to be on par with the number of hydrogens on the right hand side. So let's do that and see what impact that has on the overall balance, right? So the new equation with the addition would be 12 HClO₄ plus P₄O₁ produces 4 H₃PO₄ plus Cl₂O₁. Okay, so as you can see, we didn't change anything on the right hand side, so that would remain the same. on the left hand side we did change something, so I'll just quickly put what the right hand side would be. So here we've got 12, 2, 23, 4, right? On the left hand side we're gonna have let's actually work through that step by step, right? So for hydrogens, we added the 12 as the the coefficient in front of the hydrogen, the perchloric acid. So I mean that's going to be 12. For chlorine, this only occurs in this species, right? It doesn't occur here, so that would be, again, it would be 12. And for oxygen, so oxygen occurs in both species, so it occurs in this species, it occurs in this species, right? So you can imagine we're getting quite a bit of oxygen. I would invite you to have a go working out what our new value of oxygen would be. So that would effectively be 12 times 4 plus 10, right? Which, as you know, 12 times 4 is 48, right? So that's basically 48 plus 10, which is going to be 58, right? So for oxygen, we're going to have actually 58. And for phosphorus, well, we didn't actually modify anything. It's just going to be the same as what it was before, but you can just see here as well. It's going to be a 4. Okay. Okay. So what's really changed? So the hydrogens are now balanced, as are the phosphorus is balanced, but the chlorines, and also for oxygen, it's no longer balanced, right? Now, one of the species which you can quite clearly see is Cl₂O₄, right? And in the case of Cl₂O₄, if we added a coefficient there, it would affect only the number of chlorines and oxygens, right, on the right hand side, without affecting like the hydrogens and the number of phosphorus. So this is what our focus is on. However, we do have to select what our coefficient would be. So one of the things we can do is work on figuring out a multiplier, right? And I'm going to focus on applying a multiplier for chlorine specifically, because chlorine occurs only in that species, whereas oxygen occurs in both. So for oxygen, it would be a bit more complicated, although that can also be worked out. So for example, for oxygen, you have 4 times 4. So if you did 23 minus 16, right, it should be in effect, so it'd be 7, right? So you've got a comparison of 7, 7, no, actually wait, so 23 minus 16 is 7, and on this side you've got effectively what, 58, right? So if we subtract that as well, so that would be 40, I think that would be 40, like, so 58 minus 16 would be 42, right? Yes. So when we consider this, right, so the difference between the 7 now and the 42, so what I've effectively done is I've isolated out the oxygen contribution from the H3PO4, and I've also in effect isolated that out of the difference of that from the left hand side as well, if that makes sense. Specifically, so I can look at, well, if we're focusing only on Cl₂O₄, what would we need to scale things up by? And you can see 42 divided by 7 will tell us that, as will in the case of oxygen, well, no, in the case of chlorine, so this is for oxygen, right? But in the case of chlorine, 12 divided by 2 would tell us that, right? Right. And in both cases, what's the number that we get, right? Of course, in both cases, the number we get is going to be 6. Okay, so our multiplier is 6. So what I'm going to do at this stage is I'm actually going to put a coefficient of 6 in front of the Cl₂O₄ to see, what we're going to get from that. So I'm just going to try and separate this out from some of the rest of what we're doing here. HClO₄ plus P₄O₁ produces 4 H₃PO₄ plus 6 Cl₂O₄, right? So let's now audit this. So let's effectively work out what our values are on either side. So left hand side, right hand side. So we didn't change anything on our left hand side, so it should basically be the same as what it was before. So HClO₄P. So we've got 12, 58, 4. And on our right hand side, so if we do HClO₄P, it's important, I guess, for us to consider that we didn't actually modify in the last iteration. If you compare these two equations, we didn't modify the number of phosphorus, right? We didn't add anything to this particular species, phosphoric acid, so that would be the same, and we didn't change the number of hydrogens. So these two elements, they don't occur in this species, which is the one we added the 60. So they would be the same, and you can just confirm that there. So 4 times 3 is 12, so it's the same as this, what it was before, 12, and 4 times 1 effectively, right? So that would be 4. So what has changed is for oxygen, that's changed, and chlorine has changed, right? So for oxygen, we've got basically, let's put it for oxygen, we've got 16, so we've got 4 times 4 plus 6 times 7, right? Which is effectively 16 plus 42, which is, of course, 58, right? And for chlorine, we've got 6 times 2, right? So, which of course we know to be 12, right? So now let's compare the left-hand side and the right-hand side. What do we have? Now, if you look, what do we find? Well, what we find is that on both the left-hand side and the right-hand side, we now have the same number of occurrences of each element on both sides, right? So, and because of that, we can quite confidently say that now what we have is our balanced equation, right? So this is, in this instance, our balanced equation. So we can kind of if we go back to our question here, we can say put 12 and a 4 and a 6, right? And we could, I guess, I mean, not that we have to do this, but we could also go up here and put a 12 and a 4 and a 6, right? And as you can see, we also adhered to the other requirement, which was to make sure we only use whole numbers. So all of the numbers we've got are, you know, integers, whole numbers. So we've also kind of met that requirement too. All right.